Aaron, did you have any questions? What you got? $27. All right. Ready? Here we go. The kinetic energy generated by a 5-pound ball is represented by the formula K equal 1/2 5 times v squared. If the ball throws with velocity 6 feet per second, how much kinetic energy is generated?
Yes, I got everything for that.
Good. Any questions? Yeah, isn't that pounds? Yeah, you're right. Okay, what does the K stand for in the formula? Kinetic energy, yeah. Where does the 5 come from? Yep, 5-pound ball. This is number 27. What? Yeah, good point, Anthony. What's the V? What does V stand for? The velocity. Okay, so if a ball is thrown with a velocity of 6 feet per second and we want to find what the kinetic energy is, we're going to plug in 6 for V. So then 1/2 times 5 times 36 is 90. 90. What's kinetic energy units? Anybody know? What is it? What's the abbreviation for that? But isn't there's weight in there too. Pounds per meter per second squared or something? Okay. I don't know. Let's just go with 90. Okay. Pounds per feet per second squared. Yeah, because it's, yeah, right. Okay. Aaron, all those words just translate into, take this 6, plug it in there for the velocity. All right. All right. Easy dojo points. Kat, questions? 30? Yeah. All right, determine whether each function can be obtained from the parent function y equals x to the n using basic transformations. She did? Okay, well the answer to 30 is no. Because if you're starting with x cubed, subtracting x is not one of our transformations. So you meant 33. Okay, if I start with, yeah, it's yes, right. No, what did I do to x cubed to get negative 4x cubed? What'd you say? Multiply by negative 4. So what does that do to the graph? Uh-huh. So if you multiply by 4, that gives you a vertical stretch of 4. And then if you multiply by the negative, what does that do? Upside down. Boy, you're turning. Is that where you're going? Inside out and round and round? Upside down, you're turning me. Oh, where was Kate going? To the in-house room pretty soon. So yes, you start with x cubed and you do 2 transformations and then that'll get you that, okay? Max, did you have any questions? Okay.
Yes, but I have a question about polynomials.
Oh, okay. Okay, find a quartic. So what degree is that? To the fourth. So if I have -1 as a 0, then x plus 1 is a factor. If I have 3 as a 0, then what's a factor? X minus 3. And then I need to make this into a quartic. So we talked about this yesterday. The exponents have to add up to be 4. So what do you want for the exponents? 1 and 3. Or I can go, yeah, squared and squared. Or I could go 3 and 1. All of those will give us what we're looking for. Okay. All right, 24, same thing. Can you get 24 now on your own, Max? I think so too. Gabby, any questions? Nope. Eli? 39. Okay, so for 39, oh yeah, good one. Describe the transformations that were used to change the graph. So we started with y equals x cubed. And then we ended up with that nonsense. Anybody have any bright ideas? What's going on there? Kat? Okay, so first of all, since it's going from, I'm sure, you remember that the regular y equals x cubed graph is a down-up. And so since it's been flipped around to an up-down, then you know it's been flipped over the x-axis. So that's going to change it to be y equals negative x cubed. Okay, what else do we have? What did you say, Eli? Nothing? Okay. 2 up. Yep. So how do I make the graph go 2 up? Plus 2. Okay. That's because this point right here is 2 up from where that point right there would normally be. All right. What else we got? 4 to the right. How do I do that? Huh? Inside the parentheses, x minus 4. Okay. So then the only other thing we need to worry about is, was there some sort of a stretch? Okay. So, no, there was not a stretch, or don't sing, or both. Well, here's the way we can figure out whether there was a stretch or not. If I take, let me draw a little bit more detailed regular graph here. If I take as the original graph y equals x cubed, what is 1 cubed? Hello.
Hello.
Anybody out there? What's 1 cubed? 1. So my original graph would go over 1 and then up 1. What is 2 cubed? 8. So the original graph would go 2 to 8. All right. So if I look at this graph right here, does this go over 2 and then up 8 also? This original graph, if I start at this kind of vertex point right here, if I go over 2 and up 8, am I still on the graph? Yes, so that means that there is no stretch, because the original graph, if I go over 2 and up 8, I'm on the graph also. So there has not been a stretch. All right, so final answer that we're looking for there is that. Flipped over the x-axis, 4 to the right, and up 2. Carter, questions? 36? All right, so same deal with this one. Okay, so yeah, this one has been flipped over the x-axis also because it's going up, down instead of down, up. So I need a negative there. How far has it been moved to the right? How far has that little middle point been moved to the right? 3, because see how the x-coordinate of this point right here is 3? So that means I'm going to go x minus 3 cubed. And then how far up or down has it been moved? Down 2. All right. Yeah. So it got moved to the right, yeah. What? This is to the right, isn't it? Okay. And then this one has not been stretched either, because if I start at 3, negative 2, if I go to the left 2 and then up 8, I'm back on the graph. So y equals negative parentheses x minus 3 cubed minus 2. You're welcome. Thanks for asking, Carter and Eli. Those are great test questions. Good, good way to make sure you understand all of this stuff. No, in parentheses moves it to the. Oh, in front of it, yes, flips it over the x-axis. If I, yep, you're right. If I made this negative in the parentheses, that would flip it over the y-axis. All right. Okay, anybody else any questions? Feel like that probably covers it. Weird, isn't it? It sounds like a question for waiver. Will y'all get out a piece of paper for the beginning of our chapter 5 review? Okay, so way back in the beginning, the first thing that we started talking about in chapter 5 was naming polynomials, okay? So you might want to find in your notes that chart that had the names by degree and by number of term, okay? So we're going to be using that. And then we also talked about the end behavior of the graph. So for the first one, I need to start by putting that in standard form. So Anthony, can you rearrange that into standard form? Highest exponent first. You need to put it so that the term with the highest exponent is first, and then the next one, and then the next one. You're naming it, but we need to write it in standard form first. So that means, okay, that's fine. So the negative x to the fourth comes first, and then the plus 12. Okay, so yeah, so now it's in standard form. Okay, highest exponent first, and then the next highest, and the next highest, and then so forth. All right. So then you start to name it. What is it named by its degree? Quartic. And how many terms are there? So it is a quartic binomial. What is the end behavior of the graph? Up, up, down, down, up, down, down, up. Well, I'm glad we're reviewing it then. The degree is even, but the lead coefficient is negative. So what does even negative get you? Down, down. Don't get it. And that's a down, down. Got it. Okay, Austin, could you, oh, yeah. Minus x plus 7. Yeah, do all the variables first, okay? Okay, what's the highest exponent? 2, so that means it is a quadratic. Yep. How many terms does it have? 3, so it's a trinomial. And this one is even but positive, so it is up, 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 up. Like a dog getting in a truck. Up, up. All right, Ty, how about number 7? First, put it in standard form. Who comes first? Negative x to the 4th, Yep. Bless you. Yep, okay. So the highest exponent is the 4, so that makes it a, okay, and it's got a whole bunch of terms, so we're just going to say quadratic polynomial. And then what is the, you don't have to, no, that's not, yep, and then that is down, down. All right. Is this ringing a bell? No, not so much. Okay. Kate.
Okay.
Okay. What kind of a polynomial that is that? Cubic. Yeah, 4. So we'll just say polynomial. And what would its end behavior be? What is the degree, odd or even? And is the lead coefficient positive or negative? So odd positive, do you have your chart? No? Okay. Odd positive, yeah, would be down, up. Alright, and then the last one. Joe? Who comes first? Okay, x to the 4th minus 3x cubed. Okay. Plus 10. Awesome. And that is a quadratic polynomial. And the end behavior is up, up. Okay, nice. You guys did well with that. Any questions about those? Pretty much just looking at the chart. You got to know how to rearrange them. And don't forget, none of these had like terms, but if they do, you have to combine those. Okay. Alright, then the next thing that we did was, we did a word problem. If the volume of a cube can be represented by a polynomial of degree 9, what is the degree of the polynomial that represents each side length? So it's, no kidding, so it's a cube. So there's going to be 3 things that we're going to multiply together, right? And we want those to end up to be 9. What's the degree of each one? What? Yep, nice. Cubic. How'd you get that? What? Because 3, cubic, 3. Yeah, I don't know. 3 plus 3 plus 3 is 9. Yep, it works. So must be degree 3. Nice job, Anthony. Okay, yeah, I don't want to do that. All right. On which, number 10? Yeah, no, that's it. What is the degree of the polynomial that represents each side length? So this is a side, this is a side, this is a side, and they all have degree 3. Yeah, that's it. All right, then we talked about factoring and zeros and whatnot. So if you start with the zeros and you are supposed to write a polynomial function, these could not be any easier. Jimmy, if you know that -1, -1, and 6 are zeros, what's the polynomial? Okay, awesome. Jimmy's going to save us a little time. You could say x plus 1 times x plus 1 times x minus 6. Just go with x plus 1 squared times x minus 6. Okay, so you're just subtracting the zeros all the time. So for the next one, Kate, what does it look like? X minus 2. What does the 0 do? What does that look like? Yeah, that's going to be just plain old x. Okay, yeah, or you could put the x in front. Usually the x would be in front, but you didn't say it first, so I didn't write it there. Then you just do you then. Okay, Anthony, how about if I have zeros 1, 2, and 3? X minus 1 for the first one. X minus 2 for the second one. And x minus 3 for the third one. Nice. Okay? So you're just subtracting, yeah, just subtracting those numbers. That's it. Okay? Okay. Gabby? How about number 15? Okay. That's easy money, right? Everybody's going to get those points on El Testo. All right, so now we're going the other way. Now we have it, sometimes it's factored, I guess sometimes it's not. And so we need to figure out what the zeros are. So for the first one, it's already factored, Aaron. What makes this equal 0? No, sir. 3, yeah, 0. And what makes this equal to 0? There you go. And since it is to the third power, there's 3 of them, so we would write multiplicity 3. Okay? Yes, you can. Remind me when it's all done, okay? All right, Jimmy. This one we have to factor before we can solve it. So it's weird because it's x to the 4th. So what goes in front? X squared and x squared, because x squared times x squared is x to the 4th. And then I need 2 numbers that multiply together to be 16 and add to be -8. -4 and +4. -4 and -4. We could, but we want to factor this. So we want to break it down smaller and smaller. So now I'm going to take x squared minus 4, and I'm going to hope and I'm going to pray that at least half of you in this class recognize this as the difference of 2 squared, which very easily factors into, good, x plus 2 and x minus 2. Okay? And then this one is the same thing, so that also factors into x plus 2 times x minus 2. Okay? So now it's all you. What are the zeros? And what is true about those? There's 2 of each one. Good, so they each have a multiplicity of 2. Alright, so that was a little bit rough because we had to do a lot of factoring before we could get to where we wanted to go, but just follow the rules step by step, not so bad. All right, how about number 18, Carter? This is going to take some work. Are you ready? Are you pumped? Okay, what can you factor out of all three of those things? I can't factor an x cubed. Yeah, just a 2x, right. So if I factor a 2x out of 2x cubed, or 4x cubed, if I go 4x cubed divided by 2x, what am I left with? 4 divided by 2 is 2. And x cubed divided by x, one of the x's cancels and leaves me with x squared. Okay? Minus, same thing, what's 2x squared divided by 2x? X. And then minus 2x divided by 2x is 1. Beautiful. Okay? So that's the first step in that factoring. Alright? The bad news now is that we have 2 in front of this whole thing. And so that kind of makes the next factoring step a bit of a mess. What has to go in front to make this be 2x squared? X and 2x. X times x is only x squared, and I need 2x squared, so that means I need to do a 2x and an x. Okay? And then luckily the only two things that multiply together to be 1 are 1 and 1, so that's pretty easy. But then if I want to end up with a negative x in the middle, I need to make this one negative and this one positive, because these two things will give me negative 2x, these two things will give me x, and together those will combine to be negative x. Okay, nope. Alright, so now that we have it factored, Carter, what makes this one equal to 0? 2 times what is 0? 0. Let's do the easy one next. What makes this one equal to 0? What minus 1 is 0? 1. Good. And then Kate, to earn your trip to the bathroom, what makes this equal to 0? What does x equal if 2x plus 1 equals 0? Two x plus 1 equals 0. X equals what? Negative. If I plug negative 1 in here, 2 times negative 1 is negative 2, plus 1 is negative 1. I want it to be 0. How do I solve this for x? What? Negative 1/2. Okay. You didn't even drink all your kombucha and you already have to use the restroom? That's 32-ounce water. Are you just like really focusing on staying hydrated? I mean, you should. It's good. It's healthy. Like, yeah, if you need to use the bathroom, you should probably use the bathroom. It's bad to hold it. Anthony, thanks for oversharing there. Kate, I was just teasing you. You can totally go to the bathroom. Oh, okay. All right. Okay. Ty. Everybody goes once before anybody goes twice, Max. What makes that be 0? Eli, knock it off. 5, because 5 minus 5 is 0. What makes this be 0? Negative 2, and since it's to the second power, it's multiplicity of 2. Okay? Please go to the bathroom, Kate. You're making me nervous now. Now I have to think. Okay, 20 through 23 we're going to skip because they're calculator problems. So let's jump ahead to number 24. No, 24. Okay, Cat, a little bit more complicated. What do you need to do first? Check the note. Okay, good. We're going to add 24 to both sides. So that gives us x squared minus 11x plus 24 equals 0. Okay. Then I am going to try to factor that. What two numbers multiply together to be positive 24 and add to be negative 11? You guys are being really bad blurters today. I'm trying to call on specific people to work with them. Kat, what two numbers multiply together to be positive 24 and add to be negative 11? Negative 3 and negative 8. Very nicely done. Okay, so if x minus 3 equals 0, what does x equal? 3. And if x minus 8 equals 0, then x equals 8. Okay? Alright, so that wasn't so bad. That was pretty standard. Fingers crossed. Let's hope that continues. Alright, Max, here you are. 25. Alrighty, what do you do first? Okay, good. I have to have this set equal to 0 so that I can factor it. So since I need 4x squared in front, what goes in the front of both parentheses? Oh, 2x in both. Okay. And then I need to multiply together to be 1, so what goes in the end? 1 and 1. Okay, good. And then everybody's positive, so everybody's positive. So it's 2x plus 1 times 2x plus 1. What? It needs to add to be 4x, yes, but this 2x changes things, because if I were to FOIL this back out, if I did the inside terms, I'd get 2x, and if I did the outside terms, I'd also get 2x, and then that 2x and that 2x would add up to 4x. So it's a little bit trickier when there's a number in front. Okay, so Max, what are the... Okay. Any questions about that one? No? I know, right? Best class of the day. It's just a bummer because it's first period and then I have to struggle through all the terrible classes I have for the rest of the day. I wish you guys were like third or fourth period, kind of mixed in the middle somewhere. Like, what's that? Because then I could sort of like look forward to the best class and then sort of coast my way home, but it's like now it just gets over, it's all downhill from here. Yeah, the rest of my day is just terrible after having it. Then I go home. True. Gets me out of bed in the morning. What? Yeah, you have. Yeah. Okay, Austin, what do we do first for number 26? What's that? Subtract 27. Yeah. So I'm going to go 3x cubed plus 3x squared minus 27x equals 0. Okay, what can I factor out of? I can factor an x out. What else can I factor out? What number goes into... Oh, I wrote that wrong. Sorry, that should be a 3x squared. What number goes into 3, 3, and 27 evenly? 3. So I can factor 3 out also. So, Austin, not Max, not Eli, if I factor 3x out of 3x cubed, what am I left with? X squared. Because when you're dividing, you subtract. So 3 minus 1 leaves us with x squared. If I factor a 3x out of 3x squared, what am I? Oh, it's not a 3x squared. Yeah, I'm struggling with this problem. You guys are stressing me out. That is clearly a 3, Kate. Jeez. I can't... I can't believe you can't read my writing. It's so clear. Okay, if I factor 3x Austin out of 3x squared, what am I left with? X. And then if I factor a 3x out of negative 27x, what am I left with there? Yeah. What's negative 27 divided by 3? Negative 9. Alright, so I got that part done. Okay, x and x in the front here, what two numbers multiply together to be negative 9 and add to be 1? Do you know why you have no idea? Because they don't exist. So, when we can't factor that, what do we have to do? Quadratic formula, yeah. So I got 3x equals 0. I got x squared plus x minus 9 equals 0. Let's do this part first, Austin, because it's so easy. If 3x equals 0, what does x equal? 0. All right, for this one then, I have to do the quadratic formula. So a is 1, because we have 1x squared. B is 1, because we have 1x. And C is negative 9. So quadratic formula is on the wall behind me. I'm going to go opposite of b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So negative 1 plus or minus, this is 36, so that's going to work out to be 37 divided by 2. Okay? And I am donezo with that problem. Yeah. Ooh, great question. Yes, you would be able to do synthetic division to find that first answer, but it's not going to save you from using the quadratic formula in the end. So if we used synthetic division and we put 0 in there, and then these were 3, 3, negative 27, and 0, then it would look like this. So that would tell us that it's a factor, and then this would be our A, B, and C. Yeah. Probably, yeah. I think so, yeah. All right, let's try another one. It's going to be Eli, huh? No? Joe? What do we do first, Joe? Good. Subtract the 4x. So 2x cubed minus 4x plus 3 equals 0. Do what? Let's go straight to quadratic formula from here. Okay? What's A? Yeah, but that 2 screws things up, and plus it's got to be both negative or positive. A is 2. What's B, Joe? And what's C? Okay. So, opposite of B, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. This is 24, so this works out to be negative 8. Okay? Which is why that wouldn't factor, because of the negative number in there. What's a number that you know the square root of that goes into 8 evenly? 4. So I can rewrite this as 4 plus or minus the square root of negative 4 times 2 over 4. What's the square root of negative 4? Anybody? 2i. Good. And then the 2 stays underneath the square root. And then shiver me timbers. All of these numbers outside of the square root are divisible by 2. So I will reduce them all by 2. And this is my final answer. Okay? Some crazy stuff there at the end. Those last few problems are a little bit, a little dicey. You guys feel like you can get those, then nice job. That's some advanced algebra right there. Kate, were you able to get from Jimmy number 24 and 25? Okay. Okay, not going to solve anybody by graphing, so let's skip those. Let's do a word problem, and then we will call it a day and pick up here tomorrow, okay? So this one says the height and width of a rectangular prism are each 2 inches shorter than the length of the prism. So the height and width are each 2 inches shorter than the length. So let's call this the length x. Let's say then that makes those x minus 2 and x minus 2. Okay? Makes sense? 2 inches shorter than the, yeah? Alright, how do you find the volume of a prism? It is not drawn to scale. How do you find the volume of a prism? Length times width times height. So I'm going to go x times x minus 2 times x minus 2. And I need that to equal 40. Okay, right, 40 cubic inches. So how do I solve that? Yeah. No, it's only the units that are cubed, not the measurement itself. Yeah, yeah, I got you though, because it's cubic inches. Yeah. No, just so that's just the units. Anybody know what to do from here? Cat? No? Anyone? No? Alright, let's go to the bat cave then. So let's go x times x minus 2 times x minus 2. And let's see when that equals 40. 4.87. Works. And that would actually be just plain old regular inches. Okay, good enough for you guys? All right, we'll keep working on this tomorrow. So no homework.